Alright, and we are back live. How's everyone doing? Let me know if you can see the video or not, because I messed with OBS like a little bit and I think I might have messed it up. So 100%. No, doesn't look like I did. Okay, cool. So we are back live. Today we are going to be working on another buffer overflow. This time it's going to be within the within mostly just Windows reworking. Right now I know you're looking at Python script like right now, but yeah, it's gonna be mostly within Windows, and it's going to be we're gonna do an MP3 player and try crash that. So let me go ahead and switch you guys over here to my other guy. There we go, Windows. That's super weird, this transition and live thing. Super weird. Alright, so we go ahead and switch you guys over to that. I don't know if I like this new OBS thing that I just set up, so if anything seems weird to you guys or off, let me know. Alright, obviously there's no mic on like right now, mostly because it's connected to my VirtualBox machine for Windows, because I wanted to show my stepdaughter. She wanted to look at some stuff and wanted to see how you do this kind of stuff, so she was using an interpreter. So that was pretty cool. I also don't know if this is actually being broadcasted on YouTube or not like right now. I think I messed up bad. YouTube Studio. Yep, this might not even be on YouTube like right now, this one. So oh well, looks like it's not gonna be on YouTube today. Looks like we're only doing Twitch today. So if you're on Twitch, awesome. If not, if you're on YouTube waiting for me to come in, I apologize, it's not there today. We'll get it there tomorrow or something like that. I messed up bad. I gotta fix OBS. Alright, so like I said, we're gonna mess with this MP3 converter like right here. So I got a couple things. I got a fuzz and an exploit. I haven't tried this fuzzer yet. I'm gonna try this first. I just want to kind of see how this works and everything. See if it does actually work against it. See if I can get it to run against it. How about that? It should be able to work, but we'll see if I can get it to run. Jay, also, how you doing? I saw that you said something. What's up, man? It's a beautiful day today. So let's go ahead and open up our immunity debugger, right? We've been working with this the past couple days. We'll go ahead and attach that ASX to MP3 converter. If you don't know where to find this at, I did leave a link for it down in the Discord. And you can also find it online on exploit.db. So let's go ahead and actually look that up like real quick. We can look up MP3. What's it called again? I don't even remember what the name of this thing even is. MP3 ASX2. GitHub. Or not GitHub. exploit.db. Exploit.db. They have it on there. And I believe it's this one like right here might be. But I did leave a link to download it in the GitHub page. Wherever I did that at. And if you have an INE account, this is also on the on their site too. So it's one of these guys. Let me go ahead and open up Discord like real quick, and I'll try to drop that link into here. Let me see here. Go in general. I'll drop that link into the Twitch or something. I don't know. I'll figure it out if I can. Maybe I won't. King of the Hill teams. Hack the box. I got too much stuff on here. I'm looking for live streams, right? With live streams. Is it in here? Yep. There we go. So I'll go ahead and I'll throw this up there like real quick so you guys can see it. Let me throw this in the Twitch like real quick, or I'll throw it in the Streamlabs. I think it comes through on Twitch also if I throw it in the Streamlabs. Yep, it does. And then there you go. There's that. To be able to download that guy. So I'll come back over here. I'll actually throw it up here also. Alright, pause the video, whatever else you need to do to copy that down, and that'll get you to there also. Okay, so we go ahead and we download that, and we got it up and running like right now, right? Maybe not. F9, there we go. Okay, so now it's running. I want to try this fuzzer first, and as we can see, this actually opens up. So now we have something new now, right? We haven't had anything actually open. We haven't been messing with anything like that yet, right? So I have this fuzzer like right here that I kind of want to try. And if I right click on it, and I go to edit with idle, or you can edit with a notepad++, however you want to do it, okay? What I want to do is I want to make a file, right, called fuzzer equals open, called fuzzer.m3u, which I just double clicked on him and he did not make that, so I'm already a little bit scared. String equals a while true. There's most likely a problem with this, like right now. It's saying like, hey, like we can't do this. Usually I figure that out by going into Kali Linux and actually throwing it in there. So I'm just gonna throw it in there like real quick and see if I can do anything with this guy. Give me 1 second. Python fuzzer.py. Just gonna throw him into here. Oh, nano fuzzer.py or fuzz.py, whatever I want to call it. Okay. Just gonna save that and try to run it. So there is actually a problem right over here, it looks like, with it. Right here there's a problem with it. I don't know what that problem actually is. Saying there's a problem like right there, but what if I just need to do something like Control C and put this guy up top or something like that? It's supposed to be at the bottom, but let's go ahead and try to throw him up top. This doesn't work this time. I'm not really going to spend too much time on this. This is kind of something I would do in my own time. Try to get this guy up and running, but if he doesn't work, that's okay. Alright, that's alright though. Okay, so let's go ahead and we're going to open with idle. We're going to open up exploit.py. Now, the thing that's vulnerable here is the HTTP section. Okay. So I already have this guy set up. So you can kind of look. How you doing, Murky? YouTube is not working today, so we're going to have to only do it on Twitch, it looks like. But so we do have the prefix. It's going to be HTTP. Remember how before we put in that that kind of prefix thing where it was overflow 1, overflow 2, things like that, and knew what to connect to? This is how we're telling it, hey, you're going to connect to here. Okay, or if you watch like John Hammond, he'll put in like Trun or something like that whenever he goes to hack the Trun portion, things like that on vulnerable server or Volnet, whatever it is. All right, that's how it knows what to connect to. So we're the vulnerable area in this is HTTP. We don't have an offset yet. We don't know how many numbers we're going to throw at it. I'm thinking 20,000 at first. This does take a lot. So I'm thinking like 20,000 at first, and we'll go from there. We don't have any shellcode yet, right? We don't know the return. We don't have a NOP sled yet. But our buffer is going to equal the prefix, which is this guy, plus whatever the overflow is equal to, okay, which is the A times the offset, plus the return, plus the NOPs, plus shellcode, plus NOPs again. And then it's actually going to make a file. This will make a file, f equals open, exploit m3u, and then it's going to write it, okay? So it's going to actually make that file. It's going to write the buffer, this whole thing, right? That runs all the stuff up top to that file, and that's going to close out. So let's go ahead and try, like I said, let's try 10,000 at first. We'll hit Control S to save that. All right, and we'll go ahead and double click on exploit, and that should create a file down here, should. I don't know if it actually will, because it might be like, hey, you need other stuff in here, but I might need to do like something like this for each one after this. Let's go ahead and try to save that now and run it again, exploit. Oh, there we go, exploit. Okay, cool, so now it ran, right? So let's go ahead and throw exploit at this guy and see if he crashes really. Failure in loading file, HPA. Okay, so it had a failure in loading that file. Doesn't look like he crashed though, he's still running. So 10,000 bytes was not enough. Let's go ahead and change that to 15,000 and we'll see if we get anything. We'll delete this exploit over here, delete. And as you can see, it is running as an M3U file, because if I go to load, I know I'm backtracking like a little bit. If I go to load, it takes ASX, ASF, WMA, and one of them WMA, WMV playlist files as M3U. Okay, so it takes these playlist files like right here. So that's why we have a M3U file over here. All right, so let's go ahead and do an exploit again. We should see him right again. There he is, exploit. Go ahead and throw him up into there. And it's saying, hey, still can't find that. Okay, so let's go ahead and see in Muni debugger if anything happened. And nothing happened yet. It's still up and running. All right, so 15,000, not enough. Let's go ahead and try 20,000. We'll save that, Control S, exploit, delete him, run exploit again, get that exploit file, throw him into there. And now it's looking like we have a crash. This guy's just circling around, not doing anything. If I go to my immunity debugger, sure enough, we have a crash. and the EIP is over in 4141414141. So just like before, we want to control the EIP. We just threw 20,000 bytes at it. We don't know where it's actually landing, right? Oh, you'll get this soon. This isn't too bad like right now. This one is not too bad. If you're doing anything for OSCP or ECPPT, this is a stack-based buffer overflow. The ones that went through Murky were stack-based buffer overflows. The ones that I've done so far, and those are the ones you're going to see. This is actually way more advanced than what you're going to see on CPPT or OSCP. Both of these are. You won't even get anything like this on those. You won't have to make a file and all sort of stuff, right? But we got to 20,000 and it failed, right? So now we have to figure out where do we actually fail at, right? Like what happened there, right? Let's go ahead and go over to our Kali machine, okay? And we'll see where did this actually fail at, right? So let's go ahead and do an offset, right? Just like we would any other time. This isn't anything different. We're not doing anything crazy here. We're doing the same stuff. So we're going to do an MSF tac pattern offset. All right, or excuse me, tac pattern create. So we got to create the pattern first, right? Create tac out, and we'll do 20,000 bytes. So 20,000. Now this one's going to be a big one, but there we go. Okay, so 20,000. Yeah, if you're watching this and you're getting ready to do OSCP and you're like studying this one like right here, you've already come too far. Watch the other two videos. I'm not saying don't watch the videos. Always try to learn as much as what you can. But yeah, you've already gone too far. This is more for exploit development stuff. All right, so like your, what is it, OSXD, I think, on offensive security is exploit development, and then your for INE, that exploit development they have in there, it's like EXD or whatever. Either security exploit development, yeah, EXD. All right, so let's go ahead and hop back over into our Windows machine now, right? And we'll get back over into there. And what we'll do from here is we will now put as our shellcode all those bytes. Okay. So we'll do a Control V there. Okay. As our offset, we're just going to do nothing, right? It's going to be A times 0. Okay. We're not going to have anything in there, right? So there's going to be 0 A's that are sent, but it's going to send out the shellcode, right? So let's go ahead and save that now. Restart this program in Muty Debugger, which you will be using in both CPPT and OSCP. You will be using Muty Debugger. Now, OSCP does give you a Windows machine to run this on. ECPPT does not. So if you're doing ECPPT, you do have to have a Windows machine ready to go. You can use Windows 10 also. I did it on both Windows 10 and Windows 7, so you can do it on both. All right, just to make sure. So if I ever taught the stuff, then I won't be lying, and you can. So now we got our A offset as 0, but we put our shellcode in here of those 20,000 bytes that we made, right? Those 20,000 characters. So let's go ahead and delete the exploit. We'll save this guy up here, Control S, boom, 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 and then we'll go back and we'll run that exploit again, right? Go back and run that exploit. We should get, yep, we got an exploit down here. Make sure that he's running up and running in Muty Debugger. He is running. Awesome. And we're going to go ahead and put that exploit back into the MP3 converter, just dragging and dropping him in there. It's going to crash him again. We know that because we know 20,000 bytes will crash him. But where did he crash, right? That's the biggest thing. Okay. So our EIP is 366.95735. So now we need to go back to our Kali Linux machine. You can also do this in Mona too. This is something you can do in Mona. What we need to do, and let me kind of put these two side by side together. There and there. I don't know if you guys probably only see like half a screen like right now, but I'm just gonna go ahead and copy this down like real quick, and I'll show you what I did. Offset, and that's gonna be 20,000, and then tac Q is going to be 366.95735. Okay. So what I did in my Kali Linux machine over here, which you guys cannot see like right now, I 100% understand that. All right. I don't know what that just happened like right there. Transition this guy down over here. Okay. What I did in my Kali Linux machine is I did the MSF pattern offset. I sent a link to 20,000 bytes, right? That's how many we sent at it. But the EIP crashed at 366.95735. That's like our EIP shows that it crashed. So our exact offset now is 17417. Let's go ahead and copy that down. We'll head back over into our Windows machine here. And we will put that into our exploit. So we're just going to do a quick # or hashtag for you young bucks nowadays. Alright, and it's going to be 17417. Okay, now we know that our offset is going to be equal to 17417. So next thing we have to do is we have to figure out what are the bad bytes, right? This is the horrible part, right? This is the part that nobody likes. This is what are the bad, excuse me, we do not have to figure that out. We have to figure out if we can control the EIP value with 17417. So our shellcode now is going to be BBBB. That's the important number, correct? That is an important number. 17417 is very important because this is saying, hey, with 17,417 A's is where it crashed. So now, can I control the EIP value with 4 more B's for a 32-bit system, right? 4 more B's here. But yes, that is a very important number that we just got. Because once we can control the EIP value, Murky, we're good. That's 90% of it, like right there, as long as we can control that EIP value. So Control F2, yes, F9, start this guy back up right. Let's go ahead and make sure that's saved. Control S 1,000 times. All right. Delete the exploit that's right there, and we'll run that exploit again, and he'll make another one. Now, every time he obviously makes this, he's following what's on here. So let's go ahead and throw him into there. Go back into our immunity debugger, right? And we did not control the EIP. Huh, that's a first. 17,417 A times the offset, shellcode equals BBB. Why did we not control the EIP? That is actually a first for me. I feel like something else messed up. Maybe it didn't save properly. I feel like it didn't save properly. Let's go ahead and restart that program again. And we're going to see maybe if it just didn't save properly. This guy over here, file, save, please. Dear God, save 1,000 times. Okay. So let's go ahead and we're going to delete him, and we're going to try that one more time. Because that should have, we should get at least something here. At least A's or B's or something. Alright. Even if we don't see all the B's, like the other night, how we didn't see all of them, then we're like, okay, cool, we need to add a couple more in there. We should at least be able to see something on there. So let's go ahead and run that exploit again. This guy should pop up down here. Throw him into there. And let's see if we get that offset this time. We do. Okay, cool. So the EIP value, so I guess I didn't save it last time. I was moving too fast. The IP value is sure enough now 42424242, which is the hexadecimal for BBBB. Alright, so that's 4 B's like right there. Awesome. So now we know that we can control the EIP value. Alright, so now what we need to do is we need to figure out what are the bad characters. You notice we've doing the same things that we did yesterday and the day before that. We keep going through the same steps. Okay. Because the same thing repeatedly, doesn't matter what program you're on, as long as it's a 32-bit stack-based buffer overflow, you are going to continue to do the same steps. You just need to be able to control that EIP value. So let's go ahead and figure out some bad characters. Then from there, we'll figure out the jump point, right? And then we'll be able to send a payload at it. We'll be done with it. Okay, so to figure out the bad characters, we want to, again, use another my Kali machine over here. So let me go ahead and throw him up real quick. All right, we'll transition down to him. And let's go ahead and use our Kali machine to find bad characters, which you know that I already have a bad character script, which is also on GitHub. So let's go ahead and cat was it in desktop, buffer overflow 1, blah, 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 bad characters.py, right? This is my bad character script. So if I go ahead and do a Python 3 for this whole thing up here, for bad characters.py, there we go. Now remember, x00 is pretty much always a bad character. Alright, so there we go. Okay, we'll copy that. Also, while going through the exploit development course, I guess the X0A, I believe it was X0A and XD something, they're usually bad characters too, so, or also. So that's weird. I didn't know about that one. And then XCC can also mean something totally different than what it is. So that could also mess up your exploit too. Don't know if that's going to help at all for OSCP, but that is something that, you know, just knowledge, I guess. Other knowledge. It's always good to get knowledge. We'll transition back into this guy. Remember, I copied all those bad characters down, right? We're going to keep that overflow. We're going to keep that shellcode like right there. All right. And then we're actually not going to keep that shellcode. We're actually going to throw in, I always forget this part, if I keep it or not. I forget it every single time. And I'm pretty sure I literally said this last video that I forget it every single time. You know, I suck at this point. Every time I forget it. We're going to go ahead and we're just going to throw it in there. We're going to go ahead and we're going to throw it in right where those 4 B's are. And we're going to see if we can find it from there. Let's go ahead and Control V. Alright, we threw all of our bad characters in there, right? If I go to Home, End, okay. That last one's XF. XFF, okay. Let's go ahead and save that guy 2,000 times. Last time I had a problem with that. Go ahead and make sure that immunity bugger, is he up and running? He's not. Let's go ahead and get him up and running. Control F2, yes. F9. Get him back up and running, right? My son is a dinosaur. He just made some dinosaur noises in his bedroom. Just started screaming. Kids are great. And we'll throw him into there. Alright. Now we do still have, before I throw him in there, we do still have that offset. Okay. So we'll throw him into there. Alright. Immunity bugger. Obviously the program crashed. Okay. Now let's go ahead and go up to the ESP value. Right click. And we will follow and dump. Okay. We may have to scroll up a little bit. But let's see what we got here. We're trying to find 0, 1, 2, 3, 4, 5, 6, 7, 8, and then a bunch of zeros. So something messed up there, right? It's not supposed to look like that, correct? So what we want to do now is, since something messed up, we know it's something messed up, right? That is not correct. There's obviously some bad characters there, right? So now we need to figure out what are those bad characters. Okay, so it looks like X09 at this time is a bad character. At least that's just what it looks like to me. I don't know. Could be a perfectly okay character, but it doesn't look like it, like right now. So let's go ahead and see if X09, if that's a bad character, and if we delete that from the file here, if I can get to it, Jesus, there we go. If we go ahead and go to X09 and we delete that, then we get the same thing. If we get the same thing, then X08 is the bad character. Okay. So file, save. Oh yeah, he's a T-Rex. My son is definitely a T-Rex. Alright, he all day. Roar! Oh, you're so scary. No, just exit out of here. Alright, so let's go ahead and get back into this guy. Control F2. Yes. F9. There we go. Okay. And we'll go ahead and run that guy again, that exploit. He's supposed to be sleeping. I just heard a roar in his bedroom. Like, okay, bud. Not very quiet doing that. Go back in immunity debugger. Right click. We'll follow the ESP and dump. And we'll see if we get that same thing. And we do. So it looks like X08 might actually be the bad character, and X09 might actually be okay. That's what it's looking like right now. So let's go ahead and get back into there. And we'll say, hey, X08 is the bad character. X09 is good to go. So let's go ahead and change that 8 to a 9. Alright, we'll save him. Control S a whole bunch of times, right? Delete him. F2. Now this is the tedious part. This is the part that takes a long time. This is the part that people try to rush, and if you try to rush it, it's just going to take longer. It's one of those things. It's tedious, sorry. There's no other way to put it. Actually, I'm not really too sorry. Right click, follow and dump. Okay, so let's see what we got now. So there's all of our A's. We got 1, 2, 3, 4, 5, 6, 7. Alright, then it goes 0, 0. So it looks like, is 8 and 9 bad? Huh. Because 8's gone now. 9's back on there. And we're still getting all this craziness afterwards. See what I'm talking about there? So that is definitely a problem, like right there. And that's something that, you know, we have to look into, like right there. Are both of them bad? What are the actual bad characters here? If we get, I just feel like 8 and 9. That's just kind of crazy to me that 8 and 9 are both bad. Because 0, 0 is already not in there, right? Let's go ahead and get rid of 9 also. We'll go ahead and we'll get rid of 9 here. And we'll go from there. So let's go ahead and you know what else? I am screwing you guys over. I apologize. Let me go ahead and do appearance, font, 6 and get that bigger. There we go. Now you guys can see that this is bad like right here. I'm going to go ahead and get rid of 9 again, maybe, and then keep 8 in there. I'm going to try something like that. Let's go ahead and get rid of 9. Keep 8 in there. So let's go ahead and change this out to x0 and 8 again. We'll do 1, 2, 5, 6, 7, 8. Because I just don't feel like 8 and 9 are bad. I feel like one of them messed the other one up. Save it 1,000 times. I'm going to click on File Save. Okay. Delete that guy. Let's go ahead and restart this Immunity debugger. Like I said, this is the most tedious part. Some bytes will mess up other bytes and things like that. So you do have to just continue to look at this and continue just to comb through it and just, okay, are there any bad bytes? Okay, are there any bad bytes? So this is probably the worst part of the whole thing. Right click on ESP, follow and dump, right? And we have, yeah, it looks like, I mean, 8's bad. I'm going to get rid of 8 and 9. I don't think 8 and 9 are both bad, but I'm getting rid of both of them because it is having some problems in here right into that. Alright, so we're going to get rid of both 8 and 9. It's either that or it's that I don't have BBB plus that. That might also be the problem. Let's go ahead and try that first. Control S that a whole bunch of times because I might have messed up like right there also because I always forget if BBB is supposed to be in there or not. He did actually do it. I don't know if he'd actually take that or not. So Control F2. Yes. F9. Remember 9 is still gone like right now. 8's the only one that's still there, right? Yep, 9's still gone. I'm going to throw him to there. So if this doesn't work, we can always put 9 back, whatever else. Right click, follow and dump. Alright, and we have all the way up to 8. And then a bunch of zeros again. So we're going to go with, hey, there's something definitely wrong here. Alright, and we need to go ahead and get rid of 8 and 9. Let's try that. Save that 1,000 times. So far, let's go ahead and put these down. We got rid of x08, x08, x09. What's actually really confusing to me about this is that I don't think x08 was a bad character an hour ago. So that's what I'm kind of confused about this like right now. It's kind of like, what the heck? Control F2, yes. F9. Alright, we may also have to find the jump point before we actually do this. So we may go back and try to figure out what the jump point is. If we get another bad error again, it might be because we're not in the proper jump point. And yeah, we are. We're getting another error again. So what I'm going to do is I'm going to go ahead and do the jump point. And we're going to get the jump point before we do anything else. We're going to do a jump tac R ESP. Alright. Oh, Mona. Exclamation point Mona. Jump ESR. Jump tac R ESP, okay? And there's a lot of jump points in here. And we may actually not be able to even see them all. So usually I like to get the bad characters before I find the jump point. But since this guy is acting the way that he is, let me go and go to view or actually minimize down the CPU one. There we go. There's some jumps like right there. This guy is acting the way that he is. I'm going to go ahead and grab a jump point first. And then we're going to try this again. So I have a jump point like right here. I'm looking for one of these ASCII jump points, okay? ASLR false, rebase false, save SDH false. So everything's false on here. He is going to mini stream ASX MP3 Converter. So we're good with all of that. Let me go ahead and try to get this a little bit bigger for you guys. There we go. So this guy right here, that's what I'm going to go for, my jump point. So we're going to go ahead and grab him. We're going to copy the clipboard. We'll copy that address down. Go back into here, into my exploit, right? Not that one. Right here, right? Okay. Go ahead and throw that guy there. Control V. Okay. And let's go ahead and throw that return point into here, like real quick. Remember, it is going to be a little endian. Okay, so we're going to do a /x06. Wrong way of the slash. /x06 it looks like. /x3e. /x04. /x10, because we're going this way, right? 06, 3e, 04, 10. Okay, so we'll go ahead and throw that guy in there like real quick. We'll save him, and then from here what we'll do is we'll go ahead and send that off again. This shellcode with all the bad bytes again. Let's go ahead and actually put back in /x08. We'll start with 1, then we'll put the other one in. We'll save him, minimize out of there, and delete that exploit. So all we did was we're going to try to find a jump point. Maybe it was messing up because of that. Maybe it just wasn't at a correct jump point or whatever else. Alright, there could be a lot of reasons that this was happening, but Go ahead and view CPU. Control F2. We'll get this guy up and running again. F9. All right, let's go ahead and try this again. And we'll double click on exploit. Get that guy right there. Drop him in there. Okay. And go back to immunity debugger, wherever he's at. There we go. All right. Grab that ESP, follow and dump. And we are getting 1, 2, 3, 4, 5, 6, 7, 8. Looks like 9's bad. So then we're getting some crap afterwards. This is strange. I have not seen this one yet because, oh man, this is very, very strange. So before, when I just did this, I mean, we had just a few bad characters. And it was not this many. This is very, very strange to me. I'm thinking about getting rid of X0A, X0D, because those ones are usually bad characters. Let's go ahead and get rid of X0A and X0D. Those ones, I wonder if X0A is actually messing it up, but we're just not realizing it. Let's go with X0A, X0D. Because those two are usually also bad characters. So let's say we got rid of X09 so far, right? Slash X slash X0A slash X0D. Okay, let's go ahead and get rid of those. Let's go ahead and save that guy. And we're going to try to run this guy again. Because he is being very strange like right now. At least you get to see the troubleshooting side of this, right? F9, which teaches people usually the most, is the troubleshooting side. Double click on exploit. There's exploit. Boom, we'll drop him in there. Go back into immunity. Right click on the ESP value. Is that even the ESP value? Where am I here? Yep, right click on the ESP value, follow and dump. And we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 9 was bad. And 0A was bad, which is messing up both of them. Then we have B, C, D. B, C, D was bad, we think. B, C, E, F, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now I have to see if there's any more bad characters. Now remember, just like we saw the other day, it may not just be a bunch of gibberish afterwards. It could just be one of these might be a 00, or one of these might be 38, 39. This one might be 4D or some crap. That doesn't come after 39. 3A does. So we have to comb through this very slowly and tediously, but a lot of people mess this up because they're going against the clock, right? CPBT, obviously you have 7 days, not very difficult, right? OSCP, you have 24 hours. This is right where a lot of people mess up at because they know they're going against the clock. They have 24 hours. They want to get done with this. You got scans going in the background. You're going to have all of your stuff going on in the background. Take your time, do it correctly, get your 25 points. B, C, D, E, F, 70s. All right. I don't remember all the bad bites, so I'm just kind of coming through this guy and just looking to see if I can see anything on here that is sticking out to me like, hey, you are wrong. A1, A2, A3, A4, A5, A6, A7, A8, A9, A8, AB, AC, D, E, F, D0, 1. And we already got the jump point, so that's good. Usually I find the bad characters that I find the jump point, but we already have a jump point. So pretty much after this, after we get rid of these bad characters, and we find that jump point, we're about to make our, we'll pop up a calculator, so we can do our little, D3, D4, okay. We're about to pop a calculator so we can do our proof of concept. That'll be like our proof of concept kind of thing. And then from there, what we'll do is we will E0, 1, 2, 3, 4, 5, 6, E, B, C, D, E, F, F0, 1, 2. From there, what we'll do is we'll actually create a reverse shell back into it. Okay. So looks like it's good now with those bad characters that we got rid of. Let's go ahead and rerun this guy. Control F2, yes, F9. Okay, get him all up and ready to run. And we think that these are the bad characters, plus, of course, X00. As always, right, X00. That was our return point, right? So now let's start to actually make something here. So our shell code is obviously going to be different now. Right, we're obviously going to make this different. Shift End, delete. Okay, we'll keep the A's there. Our shellcode's going to be different. Our NOPS we'll say is /x90, which is the NOP slide. All right, which is just kind of a slide into the exploit there, because sometimes bytes shift like a little bit. We'll say this is 30. Okay, I know last time I used 16, this time I'll use 30. You can bring it down, you can bring it up. It all depends on how much space you have to be able to work with. Okay, and so now right now we have our prefix, which is HTTP, plus or equals to the overflow, which is A times the offset 17417, plus the return, which is going to be our EIP, or excuse me, our jump value, right? Plus our NOPS, x90, right? 30 NOPS times 30, plus our shellcode, which we're about to get, plus our NOPS again. That's going to create that file, and hopefully we're good to go. So let's go ahead and actually copy these guys over, because we're going to need these guys whenever we create that file, right? And let's go ahead and hop back into my Kali machine, and we'll do it just like we did the other stuff. We'll do it MSF create, and we'll go from there. So let me go ahead and get you guys back to my Kali machine. Boom, there you go. Okay, so you guys are back there, right? And we'll do an MSF Venom Attack P Windows. And like I said, first we'll do a Windows, was it execute command? Yeah, execute command equals calculator.exe. Okay, attack B, the bad bytes, right? And we actually got more bad bytes than we did last time. Last time I got X20 also. Is X20 bad? I didn't see X20 as being bad. We can try to look to see if X20 was bad. I don't think X20 was actually bad. So we're just going to pretend like it's X20 is good for like right now. Okay. And you also might get lucky and miss a bad byte, but it might be like, hey, it might not even show up in your exploit. That could be something too. Okay. We're going to get rid of X20 though. Okay. Attack F, we're going to put it in C shell programming style. Exit function equals thread. That's just to make it exit nicer, really. All right, and we'll hit enter here. And what this should do, hopefully, is it should pop a calculator. Should. If you see my face like right now, you would know that I don't really have the most faith in this, but we'll try to pop that calculator. All right, let's go ahead and transition back down. We'll put in our shellcode. We'll put that whole thing in there. Control V. There's our shellcode, right? Boom. Okay. Let's go ahead and let's actually copy that. We'll actually put that guy up here. So then, you know, it's actually in the correct place. Delete, delete, delete. Whoopsie daisy. Not that. Delete that guy up. Okay, these guys stay down there. They're good. We'll save this guy 1,000 times. I'll go to file save just so I know that he's good. He is up and running like right now. The MP3 converter. Oh, and I just got him up and running again for some reason. There we go. Okay, so he is up and running. Let's go ahead and do an exploit. Double click on him. And is something wrong here? Oh, yes, there is something wrong. That's not going to work. Delete him. All right, let's go ahead and go back to our shellcode. We have to encompass this whole shellcode, or else he's never going to work, right? So it's there. There. Okay, now that whole shellcode is now encompassed, right? And then we'll save him. Or else he's only going to run this one line of code, and it's going to start to get confusing for that programming right there. Let's go ahead and double click on exploit again. Let's throw that exploit into there, and hopefully, and yes it does, calculator popped open. So there we go, okay? That was not magic or video magic or anything like that. You take that exact shellcode actually and plug it in there and pop a calculator. So we popped the calculator. Cool. Awesome. Great. Now that was a proof of concept, right? That's not malicious. I mean, if you did somebody that is malicious, still, you know, not the right thing to do, but it's not as malicious as what we can be, right? So let's go ahead and we'll hop back into my Kali machine here and we'll make another exploit, right? We will make a MSF Venom Attack P Windows /x64 interpreter. Now I know this could be x64. Okay, actually, you know what? I'm not doing x64 like right now. We're just going to do interpreter. And we will do underscore reverse TCP. We're not even going to do that. We're going to make our life easy. Windows shell reverse TCP. We'll do it like that, okay? Because we are writing it on a 32-bit program. I don't want my interpreter to mess anything up, nothing like that. So we're just going to do MSF Venom Attack P Windows shell reverse TCP. My local host, which is my machine's IP address. So if you're used to my try hack me, it's not a 10 network. Let's go to 192.168.0.21. All right, local port, we'll do it on 4444. It's not going to be an executable file. File type is actually going to be C. All right, and then we'll do a exit function. Attack B, bad bytes, right? We still need to throw this guy in there because we're going to be copying and pasting this over. This is not going to be an executable. And then we'll do an exit function. Func equals thread. This is a really big deal whenever you're doing it for CPPT, because once you're doing it on the actual machine, you can't see it. And if you take that down, it's like 10 minutes before it comes back up again. So that exit function equals thread is a big deal. All right, especially because you're not probably going to get it on the first 200 tries until you actually figure out what is going on. All right, cool. So there's all that, right? We got that shell code and everything. Let's go ahead and get back into our Windows machine. I think I literally went through every single exploit for that and then realized, oh crap. And if you've done it, you know exactly what I'm talking about. If you haven't, you'll figure out what I'm talking about. All right, so we'll go ahead and throw that shellcode in there. Control V. Let's go ahead and open up a Metasploit listener. All right, and we can open that Metasploit listener up, and we can get so we'll do MSF console. Remember, the most important command in Metasploit is banner. All right, so we got our MSF console, banner, 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 banner. That's the most important command. No, okay. So we use exploit multi-handler, set payload to Windows, shell, reverse TCP, which is save that payload we just set up, right? Set our L host to the 192, set L port to 4444, which is the port I want to do. We'll go ahead and type in run. We've already made that exploit, right? Let's go ahead and drop back over to Windows here. And we will go ahead and get this guy exploited, hopefully. So we got that payload in there, Control S 8 million times, delete him. Let's go ahead and get that exploit running. I probably already did it. You guys are probably yelling like right now, you already did that. Let's go ahead and go there. We don't know if it's hanging because we can't tell, but we do get a command shell session. So we did get a reverse shell. Control Z, yes. Search for shell 2. Use 0. Set session to 1. Run. And then get your shell to interpreter, hopefully. Hopefully. It won't actually work because Windows 10 will actually block that. Now I think about it. So since we're over here, what we can actually do is we can like tear down the whole thing or whatever. But yeah, it won't actually work because Windows will actually block that. But we'll try one more time. We can do kill. And then run. Okay. And then go back into my Windows machine. We're going to kill it again and run again. Pretty much what we're going to do is we're just going to cheat. Just tear down the firewall kind of thing. You could get around this in real life, obviously, with uploading files and, you know, doing antivirus bypass and all that stuff, right? You could do that in real life. Show options, sessions, attack I, set L port to 1337 or something like that. Run. See if that works better. I'll just go over to the Kali machine, just change up the exploit, see if we can get a shell back. Shell to interpreter is not working like right now. That's okay. I'm not really too worried about it. You guys saw we can get a reverse shell. From there, in all honesty, you guys should be let's see here, turn on, dismiss. Here we go. That's why I actually want to shut off, like right there. How do I shut you off? Manage settings, real-time protection. There we go. Yes, please. I get off here, and we'll try the shell to interpreter one more time. There we go. That's what I wanted. Yeah, you can get turned off. Quick scan, turn on. Check for updates. No, don't ever check for updates. Ransomware protection, don't care. You can ransomware the hell out of this thing. All I'm going to do is just reload it. Allow threats, protection history, current threats. There's no current threats found. Huh. I found a big one like right there, but okay. Oh, we lost our actual session. We got booted out of it, huh? We'll go ahead and open this guy up one more time. Control F2. He's running F9. Okay. We got booted. Booted, rocking everywhere. Whoopsie daisy, I forgot to use exploit multi-handler. I'm just getting that guy back up and running everything. Alright, we can actually go back over to my Kali machine now. Since you guys just hear me clicking away, clacking away and don't see anything. Alright, Control Z, yes, search for shell 2. I don't know what that noise was by Windows, like right there. That just tell me like, hey, your antivirus is off. Dear God, please turn me on to say something like that. I hope it did. I really hope it did. Because you really want to do so much. Session stack I. Set session to 2. Run, and we'll try to run him again this time. If it doesn't work this time, just because Windows real time is up and running, and I don't really feel like actually making a entire, exploit just to get through him and then loading out Windows 2 command line and everything. So we're gonna end it like right there. But you can do that if you want to. Much easier, obviously, on Windows 7 than it is on Windows 10. But that is something you can do. All right. So with all that, what we learned today was we got a reverse shell, we popped calculator, and we utilized a program this time. We haven't done that yet. We haven't utilized an actual program like that, and we haven't actually gotten into it like that. So there's your little exploit development for today. Tomorrow, or the next day or something like that, we will be going through, let me see here, actually, let me pull him up. All right, what are you guys looking at? You guys looking at Kali? You guys are? Okay, cool. Let me actually go ahead and pull him up, and if he's logged in, then you guys can see it. If he's not, then you can't see it. See what we got here? Okay, I gotta log in like real quick, so you guys are going dark screen. Alright, you guys are seeing nothing. Sorry. Alright, dark screen. I'm gonna log in like real quick, and then you guys can actually see what's going on again. Alright, so went ahead and logged in, so we can go ahead and get everything back up and running again. There we go. Okay, so tomorrow what we will be, oh, you are very welcome. Thank you, Mr. Murphy. Thank you. Alright, so tomorrow what we're going to be doing is, so we just did, we actually did we do MP3? I don't know if no, we're going to be doing a structured exception handler exploit tomorrow. So if I come here, we have a file in here that we can actually use. At least we should. Got next. Let's see here. And let's try to exploit buffer overflow vulnerability in Big Ant server. So we'll be doing the Big Ant server tomorrow, okay? So we go ahead and grab him, and I'll actually show you guys how I actually do this with my machine and everything. So I download it to myself, right? It's a zip file, don't care. We'll say okay. And what we're going to do from here is I'm going to go into my CD, into my desktop, INE, exploit development, right? I should have Windows. That's actually base stack overflow. So we'll make a new directory. Make directory for Windows SEH overflow. Structured exception handler, CD into there. Windows SEH overflow. And now tomorrow, the stuff that we're going to be getting into, this is going to be a lot more, or tomorrow, the next day, whichever day. This stuff's going to be getting a lot more hardcore, just so you guys know. This is going to be way above and beyond what ECPPT or OSCP will ever do. Alright, so we got that Big Ant server now, right? So he's sitting in here, right? Stack LA. What I'm going to do is I'm going to make a Python server, Python tab M, simple server 8888. I can now go over to my Windows machine and go to Google Chrome and do a 192.168.8888, right? Because I made that Python server, that file stayed in there. He's going to take forever to go there. Okay, there we go. So we got our big ant server. We can click on him, and he just downloaded. So now if I go to my downloads, right, or wherever, and that's how I pass the files over into my Windows machine. Just so you guys know, that's one way to do it. There's a million different ways to do it. That's just one way to do it, okay? We can go into here. We got our big ant server set up. All right, so, yep, that's how I do that one. Cool, amazing, great, whatever. All right, and yeah, so we'll do big ant server. You guys can pause the video right where it has that on there. There he is, and we're going to do a instruction exception handler on this guy. Okay. So hopefully you guys learn something tomorrow. I'll be excited to see you guys or the next day or whatever, and we will go from there. So you guys have a good night, right? I might be back out a little bit later because my wife is not feeling good, so I'm probably not going to sleep in the bed because I don't want to get sick, because I might cry if I get sick because I'm weak. And yeah, that is about it. So have a good night, and I'll stick around for any questions. And also let's try to figure out how to fix this damn OBS. OBS is killing me. Alright, doesn't look like there's any questions, so you guys have a good one.